are on factors influencing sensory measurements, and will be the prelude to selection of panels, lectures, and difference testing and other kinds of testing, which we'll be taking up the next few times. The quiz will be starting at 11:30 on Tuesday next, and Ms. Pangborn just gave me her questions, and I've made out mine. There will be 15 questions, most of them 5 points, some of them, a few of them 10 points. And they're almost all of them definitions, or to describe, or to explain what something means. None of them are going to take more than a paragraph of writing. Some of them are only going to take a few words of writing. Now, when we started to write this book, and this may be if any of you ever get in the unfortunate position of having to write a book, you have to decide what you're going to put in the book and what you're going to leave out of the book. And the book could have probably started with Chapter 6. That's one kind of a book. But the other kind of the book was to have people know what they're working with, the tools of the trade, namely the sense of smell and the sense of taste. And when we came to that conclusion, then we felt that we needed this chapter, because these have to do with more subtle things that influence people's reactions to sensory stimuli. And in essence, this chapter explains what we now call the Davis point of view with respect to sensory evaluation of foods, that we all differ from each other, and that it's very difficult to find out sometimes why the differences occur. It's pretty easy to determine the differences just due to sensitivity because of physiological variables. That's not too difficult. But to find out how people vary in their attitudes toward foods and sensory reaction to foods from the psychological point of view is much more difficult. And this chapter proves to be the hardest for the students, I might tell you ahead of time. And I will try and go as slowly and simply as I can, but you will need to read some of this material quite hard. First of all, the attitudinal factors, the different ways of perceiving the world around us because of what we are ourselves, or what our personality is. And the first ones of these are what we call the constancy factors. That's the reaction to objects in space or in terms of their known color, shape, and size. People are sometimes object-minded and sometimes stimulus-minded. And this leads to these different kinds of ways of looking at the world. If I put a picture up here on the board, if I just put this card up here on the board and put it down, you would all have different reactions to it. Some of you would make a very casual survey. It's a card, it's sort of black. Others would have noticed that there was 2 Greek letters at the top of it very quickly. Not very many of you could see close enough to see that it had sigma xi. Some of you would have noticed that it had red markings up at the top. Others of you would not have marked. Some of you would have said it's a postcard or something like that. This then is the casual survey, or people who simply look at things in a very casual way. Others are more inquiring. They will inquire, why would he be putting that card up, and things like that, and the details of it, the colors, the kind, some part of it is printing and part of it is writing. Quite a large number of things that could have been observed in a short period of time. A few people are in the fortunate or unfortunate position of making a critical survey of the observer observing himself. He was saying, here I am in room 107, Cruise Hall, looking at Amerine lecturing, and I am the person that's observing it, and I am supposed to give a reaction to what's on that card up here. The person himself becomes a part of the observational process. You see yourself observing the object. That, to me, those people are not so fortunate as the people who don't. The critical particularizing, those are the people who pick out The inquiring people are the ones that are inquiring why this is being done and all the particulars about it. But the particularizing people are the ones that would have noted that there was a clip on one side of the board, of the card here, and that I was holding it in my left hand, and they would particularize every single thing about that particular card that I was putting up here. Other people will evaluate things in terms of pleasantness or unpleasantness. Now, this is probably true in the food world more than it is in vision and hearing, where these terms have been most studied. I don't like spinach, and therefore they're never going to give 10 points to spinach, because spinach is not pleasant, and the best spinach is not worth anything anyway. And so you view the whole world that way, in terms of what you find to be pleasant and unpleasant. There's some people who are very difficult to please. And they're also going to be very difficult to please in a sensory evaluation sense, in trying to get meaningful results. There are a few people that will evaluate things in terms of some conventional standard that has nothing to do with their personal opinion itself. It's an impersonal evaluation. Well, this is a different kind of situation, but it's this kind of induces this kind of an error, the impersonal evaluation. People who, I had a friend at one time, a lawyer in San Francisco, who was always getting up and after big dinners where there were a lot of wines were served, and giving a sermon about the wines and then telling us all about them and so forth. Now, actually, the poor man could hardly taste. He got all of his opinions out of a book. He read about it ahead of time. He never would talk about a wine if it was something he hadn't read about. So he didn't give his own opinions at all. He gave an impersonal opinion. It appeared to be his opinion, but actually it wasn't. There are quite a number of situations where this probably exists. The teacher says that this is a good beer, must be a good beer, but that isn't what the question was. The question is, what did you think of the beer? Or what did you find in the beer? So that this becomes sometimes a problem. These affect the response to food. Also, another problem that has been found in food because of these kinds of attitudes is that the instructions must be very explicit. Don't leave anything to chance, or they will put themselves in one of these different kinds of attitudes and will judge the wine minutely, or they will judge it just casually as a whole. They will particularize about every single thing in the wine or in the food, whatever it happens to be. And not be giving the kind of opinions that you wanted. Maybe all you want to know about the food is it sweet enough. If you don't give those instructions that you're just involved in sweetness, they're liable to go off on all kinds of other tangents that are not a part of what you're studying at all. So these attitudes do affect the development of scorecards or the development of reaction cards for people. And when you know that you have all these kinds of people in your environment, you cannot leave anything to chance as to what they're reacting to. Now there's some other possibilities. These have been studied by various people under various situations, and in these cases they've actually been tested as to their validity. The first one is by observation. These have actually been experimentally tested. The analytical person versus the synthetic person. The analytical person is the one that gets to all the details, particularizes about the details, whereas the synthetic person takes the whole view, puts all the things together, synthesizes a single unified opinion about the world, the sensory world. The objective versus the subjective person. The objective person works very slowly. He gets each detail right before he proceeds to the next one, and so forth. Whereas the subjective person makes a broad personal inspection of whatever the object is or whatever the food is, and immediately writes down his personal opinion about it. We observe this particularly when we're using the flavor profile technique, how different people look at food. Some people will start right at the beginning with the first odor, which is what you're supposed to do in the flavor profile procedure, and very slowly and cautiously move from one point to the next trying to be completely objective about each one, and finally come to the whole conclusion. Whereas other people will immediately say, I smelt this, I tasted this, I smelt this, I tasted this, and the amounts of it are thus and so. They're likely to have certain kinds of errors, which I'll point out again, the subjective people. Active versus passive types of experimenters or people working with foods. An active person is something like the objective person. He makes a rational attempt to make some sort of hypothesis about the problem that he has, whereas the passive person does not make a hypothesis. He just proceeds by trial and error. He uses what is now called the Edisonian approach, named after Thomas Edison, who never made a hypothesis about how to make an electric light or a photograph or anything. He just stayed up for 3 days and 3 nights and tried 3,000 things. And out of those 3,000 things, he hoped he would get something. And sometimes he did. In his time and place, the Edisonian approach, there were so many things to be discovered about electricity, and there were so many that that approach was successful. But nowadays, we would say that that kind of approach to our problems would not be a good one. The passive person also uses his immediate impressions without testing them out completely. The confident versus the cautious person. The confident person reports the details. They may not be real things in some cases, and he reports things that are not actually there. And this leads me to the subject of errors of the first kind and the second kind. The confident subject is likely to make an error of the first kind, that is, reporting a difference where none exists. Reporting a difference where none exists. And he minimizes errors of the second kind, that is, failure to find a difference when one exists. So the confident person then is likely to report a difference where none exists, and he tends to not to find differences when they actually exist. Whereas the cautious person, the situation is exactly the reverse. The cautious person will have more errors of the second kind. That is, he will fail to find differences when they exist. But he's less likely to report a difference when none exist. He's so cautious that he's not going to be taken in by that situation. Now, these errors are reported, are defined later on in this chapter, and they're defined on page 438, and they're also defined on page 252, and it's the 252 on 324. So you have them on 246 correctly defined, and you have them on 324 and 438 correctly defined. Now you'll have in 438 you have to remember that the definition of the error of the first kind there and the second kind is concerned with the null hypothesis. It's not concerned with the same definition we're given here. So it is correct. It is concordant with this. The error on 252 is that they have been reversed, and there is a real error on page 252. So on 252, will you all write on your copy, if it hasn't already been written, that the error of the first kind should be the error of the second kind, and the error of the second kind should be the error of the first kind. Then it will be consistent all 4 places in the book. I don't know exactly how this got into there. I used to worry about the one in page 438 till I realized that the one in 438 is based upon the null hypothesis, so that makes it come out all right. The other 2 are right, but the one on 252 is wrong. All right, some other kinds of errors that might be possible in foods. The color reactors versus the form reactors. This was studied a tremendous amount in the last war in training pilots as to which would be better, to train them on form distinctions or color distinctions. A fighter pilot going to whatever they went in the last war, 1,000 miles an hour, has to be doing a lot of different things. And which will he react to better? Colors on the instruments on the panel, or shapes on the instrument panel? And they found that people reacted differently. Some people reacted better to color. You could have a red dial, a green dial, and a blue dial, and they would hit it every time just out of the corner of their eye and turn it properly. Whereas other people would put their hand over and feel it and do much better because one dial was square, one dial was a diamond, one dial was hexagonal, and so forth, and they reacted to form. So these two kinds of people actually exist, and the Air Force actually studied this during the war and published on it after the war. Then there's similar to that is the visual versus haptic. Haptic meaning skin or feeling sensation. There's some people that react more to visual signs of any kind, and others that react to touch or to movement sort of things. As a matter of fact, in the final analysis, what did the Air Force do? They didn't do both. No, they used primarily the form reactors, so that the instruments the dials were turned in different shapes that they had to move. The valves they had to move were at different shapes. They did use, however, some color things for danger signals. What else did they use that has to do with sensory evaluation to get pilots so they would be better? Well, they tried odors. That when the gasoline tank got to a certain critical level, or the oil got to a critical level, they released odor into the cockpit of the plane, and that alerted them. But some people were not very sensitive to that, and so they stopped that experiment and never did do anything more. But because some people just are so intent on something else that they don't breathe deeply enough to get any of the odors up in the top of their nose, so that they were not reacting very much. I suggested they use worse odors than that, and then they would react to it, but they didn't. All right, there's three more kinds of people. These were based on a German school of psychology called Anschauungen, which has to do with our reaction or attitude to stimuli. The theory about this is that we are living in a world in which we have to filter out the sensations we like and filter in the sensations we like and filter out the sensations we don't like. That the world is coming into us with so many different outside things, sensory things, that unless we did this, why, we would be overwhelmed by the world about us. And so from this they define different kinds of people. That one's called the levelers and the sharpeners. The levelers are the people who look at we'll say a plate of food, and they make the stimulus as simple as possible. They don't distinguish between different things that are on that plate, smells and taste and so forth. Whereas the sharpeners look for differences. They're the nitpickers. They find every detail of the differences between the food. They're the people that can accept all of these sensory things from the outside world without getting mixed up, whereas the levelers are the ones that keep out a lot of the things from the outside world in order not to get mixed up. Of the two, the levelers make the most errors in sensory tests, both kinds of errors, as a matter of fact, of the first kind and of the second kind. Also, we differ a little bit in another way psychologically, and this is particularly true in tasting very poor foods. There are some of us that just don't like to have poor quality foods around us, and we react to them not only unfavorably, but we usually will reject them completely, even though they may have some merits to them. Whereas there are other people that can accept instability or low quality or unpleasant things. That's what that instability means, unpleasant things or low quality things. They can accept them. Sometimes they can put them in perspective, sometimes they can't, and they look at the world quite differently. If you were trying to eliminate bad samples, then the persons that are resistant to instability are probably the ones that you would use. On the other hand, if you wanted to get as many samples passed as possible, you would pick up the people that had accepted instability or accepted poor quality and use them. Well, I won't say anything about the physiognomic or literal attitudes. It's not really pertinent, we've decided. The next thing we're going to talk about is motivation. Motivation is a very important thing, very valuable if it can make the observer more observant and more selective about the experience around him. And it is true that when we're highly motivated, we do become more selective and more observant. If you're trying to please a young lady or a young man, you may be very much more observant of his tastes in foods or whatever it might be, or his taste in music, which kind of music does he like and so forth, than if he's just another person who doesn't concern you at all. In other words, if you're motivated to be pleasant to the other person, then you will be more observant of the other person's opinions, prejudices, and preferences. This has been done a lot of times. It's now generally called, in psychology, the payoff function. The payoff function. There is some differences in people as to what kind of motivation is going to move them, however. If the observer doesn't have any need for something, if it's not personally important to him, then the motivation may not be very important either. A person that's getting a couple of $1,000 a month check from home is not likely to be motivated by $1 to come up and smell samples as much as the one that's getting no money from home, and the $1 represents another ice cream cone for him. It may be, theoretically, that at low stimulus levels, the motivation thing will focus attention on the stimuli, particularly the relevant stimuli. And that if you're motivated enough, you know there is going to be a difference there. You rule out, because of this high motivation, all the irrelevant stimuli and focus your attention just on the relevant ones. So that motivation, we know, does make us more observant, and it may make us more observant because it makes us focus our attention on what the relevant experience is. The payoff function, where you have rewards for the correct answer and penalties for the incorrect answer, has been used tremendously on animals, of course, and that's how you train rats and things like that, is on the payoff function. They get 2 drops of sugar solution if they press the right button, and they get an electric shock if they press the wrong button. These 2 kinds of motivation will force the rat eventually to learn whatever you want him to learn. Even very complicated pathways can be learned by this. Which one of these is the best? The payoff that gives you something is better than the payoff that penalizes you something. Rats that are given a reward will learn faster than rats that are given a shock to get the right dial or whatever it is they're being asked to do. That's particularly true if the penalty is not very strong. But if you make the shock really so that it shakes them, then they will react to the shock treatment pretty well. Unfortunately, you can't use this as much as you would like to. You can't use this on taste panels. You can only use the monetary payoff or the payoff, the reward. You can't make them drink some cold, very, very strong black coffee or something like that if they get the thing wrong, or certainly can't give them an electric shock. Although there are some cases where I've been tempted to do that sort of thing. Now, knowledge of the results is a motivation. It increases the efficiency. You learn faster. There are 2 aspects of knowledge of results. One is that By the knowledge of the results, you learn what your mistakes are. And having learned your mistakes, you then learn to avoid them. If you find out that you were wrong in saying that one sample had more off odor than the other one, the next time you do that, you will say, now what did I say was the off odor last time? Well, it's the other one then. So you do that. The other way that knowledge of results improves our efficiency is that nobody wants to be wrong all the time in comparison with the other people. He wants to be better than they are. And it's about the senses, we are all very individual. We think we can smell and taste as well as anybody else. And so when it's posted every day that you're the one that gets the most errors in a triangle test, that'll motivate you to do better very quickly. And in addition to that, when that's tied up with the payoff function, namely that if you stay on the panel, you're going to get 15 minutes off in the morning extra, or there's going to be an extra $5 in your check as long as you stay on the panel. Those two things together will improve your performance very, very markedly. The interest in the test is one of the most critical things, and I want to read something that Dawson and Harris wrote some time ago. And I think that this may be a critical thing for you if any of you are going to do professional work in this field. Successful conduct of taste panels, or sensory panels, is frequently as much a matter of human relations as a scientific problem. Panel members must have a keen interest in their tasting ability, or smelling ability, and these feelings must be sustained, kept up. Informal conferences should be held periodically, and imagination and suggestion must be eliminated. We'll talk about that in giving instructions for that. But the test has to be important to them, to take them away from some other kind of work and make them do good work in the laboratory. We maintained that when we had the long series of wine experiments by giving them samples of wine occasionally, by having them stay over for 15 minutes and discuss with the project director, Mr. Filippello at that time, what we were learning from the experiments and why they were important to the wine industry and so forth, so that everybody felt that this was something that they were doing that was good for humanity and was good for the university and was good for the department, and that the results really were truly meaningful. And with that, we got very good attendance records, just remarkable. People would stay over from leaving town on a Friday in order to be sure that they got their test in. Or if they didn't miss for sickness sake or something, they would religiously come over and make up their samples. Those kind of judges are very seldom found, and it takes a lot of effort on the part of the person conducting the test to make this sort of thing happen. Money alone will not do it. Some personal interest in the test is required. Now, some people respond to praise more than others, and so you have to be careful about that. Some respond to criticism more than others, but you have to be very careful about that too. It's been shown that people who have children who have a inferiority feeling about themselves respond to praise very much. A child that's been repressed at home or something like that, in teaching him, praise is wonderful. But the self-confident, the cocky kid, the superior attitude person, will not react to praise very much. He's had that already, and he knows that he's good anyway. But a little criticism will make him shape up and perform better. So that you have to be careful how you use this criticism and how you use the praise. I can say from the professor's point of view or the teacher's point of view, this is the most difficult decision that you have to make in a laboratory course, is which ones to praise and which ones to criticize. Because if you criticize the wrong ones, people that are sensitive and already have an inferiority complex, you may drive them completely out of the class. And it has happened to me, and it happened to anybody that teaches. As you get older, you don't do that as much. You can't even do it in fun to some people. Even though it's a joke. And you smile when you say it and so forth. It doesn't do any good. Praise is the safest thing. It won't hurt the self-confident one. It may not do him any good. And it certainly will help the less confident person. Well, in general, people that are successful in a sensory test will continue to be successful. And the opposite thing is true, too, that they will get discouraged if they're not getting a high degree of performance. This is why in setting up sensory tests, we usually start with very simple things so that everybody gets 95% correct or something like that, and get them hooked into the test, liking to do the test, understanding how to do the test, and so forth. And then at that stage, you lower the odds in favor of them getting it correct to something that will be meaningful in terms of the experiment that you want to do. But don't start with very hard things. You'll discourage them right away. And they'll get bad results, and that will breed more bad results. And finally they say, well, I don't think there is any difference in these samples. And they won't come back. But if they are successful at the start, they will come back, and then you can make the odds higher. They also may be getting better with a little training. We'll talk about training next time. And then finally, the relationship between the investigator and the observer can be very important and very critical. That little thing I read you implied that, but I will have to say that, in our opinion, that's been one of the best things that we've discovered here at Davis by actual practice, that people who are conducting sensory tests smile, they seem glad to see you when you come in, tell them how well they look today and so forth, things like that. Try and establish some personal relationship with them, their name, what they do, how many children they have. All those things count up in interest between the observer. And also make them want to help you. If you're so concerned about them, then they want to help you. And helping you means doing a good job on the sensory test. So don't neglect this, although it sounds somewhat forced. In actual practice, it works. The bored person is more to be feared than the inaccurate person. You can train the inaccurate person, but somebody that's bored on the panel, that just doesn't care, he's going to be a liability for you for the whole test, because you're never going to know whether it's his real judgment or whether it's just a judgment because he didn't care and he never even looked at the samples. He went in and did 3 pairs of samples, and the results he gave you were by chance alone. He really wasn't doing the tasting, so he might as well not have been on the panel. In fact, he's worse than not being on the panel. He levels out the differences that you're finding when you add him up to all the other statistics, and you may not find a difference because of the bored person. There may be a real difference between the samples, maybe a minor one, but a real one. But the person who doesn't care, he will just say one by chance alone, mark one or the other one, and he's to be feared. Whereas the inaccurate person, you can eventually siphon him out, and or you can train him, and most people are trainable. There's one other thing about the motivated judges that we found, that motivated judges in descriptive tests are much better than people that are not motivated. If you motivate them, they will describe, their vocabulary for describing is larger. They will learn a vocabulary if they don't have one. Whereas the non-motivated person, even after you've had him on the panel for a long time, will not have very much more vocabulary than he started with. And he won't really make any effort to learn a new vocabulary. So try and motivate people. The praise is one of the things. Money is the best payoff there is. There's no better payoff than money. $1 for every correct result. You'll see people will jump right through fire. They didn't do that last night, but they did everything else. That was the most amazing performance. If you didn't see it, you missed a... How many saw the Chinese last night? It was absolutely wonderful. Only one? Didn't you think they were good? Gosh, they did things that I didn't think could be done, and particularly the ones that were, I was just remembering now, the ones that went through the hoops. They were just like snakes going through the hoops. They could go through the top hoops, the bottom hoops, and not once did they touch one. I just wondered how many times they had to do that to get a perfect performance. So thousands of times. All right, so much for motivation. Now on the other side we have some errors, and there's another error in the errors that that errors 5, 6, 7, 8, 9, 10, and 11 were omitted. So we'll do the first 4, and then you're going to have to add 7 more errors that for some reason or other got omitted. The first error is the error of habituation. These are cautious people. They have a tendency to continue to give the same answer. Let's say that we're doing difference thresholds. And you give them a standard sample. And then you start increasing the concentration. In an upward direction, slightly more. Let's say this is 3% sugar, 3% sucrose. And then you start at 3.1, so they have a pair. You ask them, is there any difference in sweetness between this one and this one? And they either say yes or no. And you keep going up on this scale until they say there is a difference. There is a difference. Now this is called the differential threshold, and it is also called a JND, a just noticeable difference. A just noticeable difference. JND. This is considered one step. We'll talk about this either at the end of this hour or the beginning of the next period, about what these JNDs actually mean. There's also another one. You could have started down here with a very low concentration. And move up to this. Could have done it from above, either way, it doesn't make a difference. Until you get to some place, you're comparing this with this. And then you compare this with another concentration, which is, let's say this is 1.5, and this is 1.6, and 1.7, and 1.8, and so forth. You're coming up in concentration. You're comparing the standard with this. There is a difference. There is a difference. There is a difference. There is a difference. And at some place you come to a sample in here in which you cannot tell the difference statistically between the standard and the concentration near the standard. And this difference here is called a J and ND, a just not noticeable difference. A just not noticeable difference. Now, in the error of habituation, the person that's doing the error of habituation, he is habituated to find the same result. In other words, as he goes up the scale, he keeps saying, there's just not any difference, there's just not any difference, just not any difference. And he may pass this point. He may go on up to here before suddenly he realizes that he's passed the point. In other words, he's habituated to finding that there isn't any difference. That's in this one down here. Or he's habituated to finding there's just a noticeable difference, and he makes this too high, and the other one makes it too low. So in habituation, you go past the point. Whereas in the error of expectation, where you know that there's going to be a real difference here someplace along the line, you jump the gun and you say it's right here before you get very far, because you know sometime it's going to occur. The eager beaver does that all the time. He will anticipate, or he will expect, that's what it says here, he will expect. So in the error of habituation, you get a larger J and D. In the error of expectation, you get a smaller one, because since he's anticipated where there's going to be a difference up here, this difference is going to be real small, and just exactly like I drew it on the board here. He's not going to find a very big J and D. So what do? Well, you have to give him the test both ways, because from the below and above, because the errors then tend to cancel out. If you give him the test from going up to finding just a difference, and also from going down to finding just a difference, why then these will tend to to cancel out. And in doing this kind of test for absolute, for difference thresholds, this is what we have to do. The stimulus error is present in all of us. At some time or other in our lives, we will react to a stimulus error. That is, we will react to something that isn't there. Example that's given in the textbook is as good as any. You give wine judges wine with screw caps and with a cork finish. Cork is where they put a 2-inch cork in them or a 1.5-inch cork in them. And the others are screw caps, which are just screwed on. Now every wine taster knows that in general the screw cap wines sell at a lower price than they do the ones that have a cork finish. They will react. If you give a taster wine with a screw cap bottle and one that's got a cork finish, same type of wine, they'll always prefer the cork finish one. They won't pay any attention to the wine itself. They're judging the wine on what we call a stimulus error. It doesn't have anything to do with the wine that's in the bottle. You may have changed the wine from the cork finish bottle into the other one, but you're still reacting to it as if there was a meaningful difference between them. The public does this all the time. It's a terrible thing from the public, from people who don't know. Another stimulus error in somebody buying clothes in a store. Just because it's more expensive doesn't always mean it would look better on you. They're reacting to the stimulus error that it's the price on it that instead of how does it look on me, that's what you're really buying. A suit for yourself to look well in. And the price of it may or may not be related to how well it looks upon you. Well, you can conjure up lots of different kinds of stimulus errors. The use of irrelevant criteria to judge a product or to find a difference with, and so forth. Now the next error is a stimulus error, the logical error, although there are cases where the observer thinks that one characteristic will influence another one. In other words, you're talking, and we had an example of a logical error last time, that pear nectar colored yellow tastes sweeter than pear nectar colored green. That must be a logical error partly. There may be some real differences too, which we haven't discovered yet. I told you that last time. We didn't know why this occurred. But just because green pears are not sweet and yellow pears or orange pears are sweet, then when we're judging differences, we find them according to the color. But that's not what we were judging in that particular thing. We're not supposed to be influenced by the color. And that would be what we call a logical error. Another logical error that was present in a big experiment in fumigating soils. They had a material to fumigate soils so that carrots would not get any worms in them. And they came into a laboratory, a sensory laboratory, to be judged. And everybody preferred the carrots which had come from the soils that had been fumigated, even though they had an off odor, because they were more carrot-looking. The fumigant had changed the color of the carrots. It made the carrots more yellow. And the panel actually preferred the rotten-smelling but more yellow carrots, more orange-colored carrots, than the ones that came from the unfumigated fields that occasionally had defects in them and so forth. Preferred them to a high degree of statistical significance. So a different kind of test had to be devised to find out about the carrots, a test in which the color was not a factor. And that was done, and when they found that out, then the people picked up the off odor in the fumigated field carrots and rejected them. And the differences were significant the other way. Now, the color didn't have anything to do with the off odor, but people were using it, you see, and they got the wrong result. Logic can sometimes can do us in. This is controlled. This error is controlled. Well, the stimulus error is controlled. I should have said the stimulus error is controlled by training. Just fool a person once, and he'll get over it. I told the story before. Those who've heard it can excuse me. At one stage when I thought I knew something about wine tasting, some friends of mine pulled a real dirty trick on me, but I learned a very important lesson from it. German Moselle wines are all in green bottles, and German Rhine wines are all in brown bottles. So I was invited to a fancy dinner, and it was at the time when I knew everything about wines. There was nothing I didn't know. And so you go through that stage, I suppose. And so they asked me how I liked the Moselle, and I gave a long lecture about how good the Moselle was and how typical of Moselle it was, and it was just like a Bernkasser Doctor, but not quite as good. And it showed that the Moselle wines had a unique and distinctive flavor. And then the Rhine wine came, and I said, now that shows how much different Rhine wines are than Moselle wines. And you can see that they're bigger, they're more alcoholic, they're more flowery, they've got more alcohol and so forth. And then they showed me that they had just reversed the bottles. They'd taken the Moselle wine out of the green bottle and put it into a brown bottle, and they'd taken the wine out of the brown bottle and put it into the green bottle. And I had been exactly 100% wrong, and that taught me the lesson not to pay any attention to the color of the bottle, the label, the year, who's serving it, what the price is, or anything. If you're asked to give an opinion on any sensory object, or in general, this is true of any aesthetic object, give your own opinion. Don't give somebody else's opinion. That's what you're asked to do, and that's the important thing. And if you do that, you won't make these kinds of mistakes. So experience is the only thing to do in getting rid of the stimulus error, the irrelevant criteria. The logical error can be gotten rid of by eliminating the unimportant things. Eliminate the color, and then you will not be using that as a criteria for the quality of the carrots in fumigated fields and so forth. All right, now the 5, 6, 7, 8, 9, 10, and 11 are not on your outlines, and I will go through those now. The next is the error of leniency. These are all discussed in your text, but they somehow or other got left off when the girls were typing. The error of leniency. Many people are easy raters. They rate things very easy. Other people are very hard raters. And this introduces an error, because if you get more easy raters on your panel, why, all the samples are going to come out tasting good. If you got a lot of hard tasters on your panel, well, all the cookies that you've labored on are going to come out smelling worse than they really are. And this error has been demonstrated in educational matters much more than it has in foods. But we think that it is present, and it may be, in some cases, that the errors are motivated by a stimulus error that, after all, she's a very good cook, or he's a very good cook, and he must have good food. And so that they're very lenient in that, and they'll be an easy rater for that. Whereas if they're having food in somebody's house who's known to be a lousy cook, even though he brings in the best food in the world, they may not. And they may be unlenient. We have the error of leniency and the error of not leniency, the easy raters and the hard raters. And they may be influenced by other things that are, or they may just be that way, as a personality may be that way. Hard to know how many of them you've got. The error of central tendency. This is a very important error in scoring, and in general is a very difficult one to get around. And you will all be using it in the laboratory. You'll all be subject to it a great deal of the time. The error of central tendency is never to use the extremes of the scale, never to say anything is very bad, and never to say everything is very good. Just to utilize the middle point in the scale. We all do that because we don't want to be wrong, and we know if we use the ends of the scale, we say that something is very, very good, when in fact it's just ordinary. Well, we're going to be a long ways off in points. Maybe the difference is 5 or 10 points. Whereas if we stay right in the middle of the scale, we can't be wrong more than 1 or 2 points. And in scoring, the thing to do on this, of course, is to anchor the scale better, to force people to the extremes. by putting descriptive terms on the ends so that they have some relationship to the end. They know that that means the best beer that I ever had is going to get 20 points, or the worst beer that I ever had is going to get 2 points or 1 point. Other adjectives can be used to anchor and spread the scores apart as much as possible. Otherwise, the scale is not all effective. You're only using a part of the scale. And since some people will be having the error of central tendency, whereas other people who've had great experience with the scale will be confidently using the whole scale, then you're tending to reduce the differences. We just had an example of that just before I came over here. There's been some special samples made with a special process, and some people came in from the industry to taste them, and we had some panel scores there. Well, the panel scores were made by a mixed panel. It was not all experienced and so forth, and the differences were not very great between the samples. But when it was done by a small group of very experienced people who had a lot of experience with this particular process of making the wine, the scores spread out over a much bigger range. And even with just the 5 samples that I'd had before I came over here, the differences were very, very much greater and obviously much more significant than the ones that a panel that had a lot of people who were just using the middle of the scale on the panel. All right, the contrast error. This is an error that I don't know if we can ever avoid completely. This has to do with quality distinctions. You give a person a very, very good piece of apple pie. That's your first sample. You come in. And then you give them a very bad piece of apple pie. The contrast between the good apple pie and the bad apple pie will result in that this will be scored lower than it really should. Let's assume that this scored 20. And this would normally have scored, if it had been just taken up by itself, would normally have scored 10. That would be the normal. But in contrast to the very good apple pie, this tastes worse than it really is, and it will score 8 or 7. It will score lower than it really is. That's called a contrast error. Because of the high quality of the first sample, we are reacting against the poor quality of the second sample. The other situation can also apply where you have a very bad sample at the start, where it does score 10 at the start, and then you give it a good sample, we'll say the same good sample that you got above, where you scored a 20 when it came first, you may now score 23. The contrast error has made this appear better than it really is. Scored 3 more points than it did by itself when you tasted it alone as the first sample. Now, of course, if you do both before and after, the errors tend to cancel out for a large number of people. But this means that you have to reverse the orders. And we had, in a seminar yesterday, we had a very good example of this. How many were at Viticulture seminar yesterday? Well, in the Viticulture seminar yesterday, you had this error, this contrast error. We had a man that had 5 samples, 3, 4, no, he had more than 5, but anyway, we'll say it's 5 samples. So he tasted the first sample first on the first day. The next day he tasted the second sample first and the 1 sample last. The next day he tasted the third sample first and the second sample last. And the next day he tasted the 4th sample last and the 3rd sample last, and the next one he tasted the 5th sample first and the 4th sample. And he purported to find that there were positional effects. But what he didn't do, he never had in a single case sample 1 following sample 2. He never had the situation of 2 followed by 1. Every case, see here it's 1 and then 2. Here it's 1 and then 2. In no case did he have the opposite thing. And so he's introduced a contrast error. We don't know how important it is or whether it's important or not. But when you're doing series samples like this, where you have large numbers of series, you have to randomize the order of presentation, or otherwise you're likely to get into contrast effect. And do all possible orders in many cases. Depends on how big the differences are in some cases too. If the differences are not very great, then the contrast error may not be operative at all. But if the differences are quite large, you will surely have contrast errors. This has been studied with foods. It's very hard to prove this statistically in some cases, but what has been shown very definitely, at least with respect to cakes and some things like that, that in the contrast error, there was more awareness of the positive values in the good samples if the good sample came after a poor sample. If you gave them a poor sample and then you gave them a good sample, you can show statistically that they will be judging the positive things in the good sample more critically and more appreciatively than if you hadn't had the bad sample first. So the contrast error has been statistically proven up to that point. The opposite situation of the bad sample appearing worse is very difficult to prove. And a lot of other kinds of factors get in when you have bad samples coming in. The next error is the proximity error. If you're judging color, taste, and odor all together at one time, you'll get one result. But if you take color by itself as a separate entity and judge it, some other time you take taste as a separate entity and judge it, and another time odor as a separate entity, then you get different values for these. In other words, the proximity error tends to introduce some confusions between the contribution to each of the senses. Now, to get rid of the proximity error, you have to have trained judges. If they have trained judges, they automatically will look at color and they'll pay no attention to taste. Matter of fact, when I start with a class in sensory evaluation of wine, the first day I tell them, don't smell the wine, don't taste the wine until I tell you. And so they have to wait there eagerly trying to get that wine in their mouth and so forth, and look at it for a while. And after they've looked at it for a while, then I let them smell it for a while. And after they've smelled it for a good period of time, then they can go ahead and taste it. This is to avoid this, what is called the proximity error, that things presented simultaneously and judged simultaneously tend to have less differences than if they are separately evaluated. You find more differences if you evaluate them separately. Now, quite frequently we can't afford to have them come in 3 different days. One day to judge the color, one day to judge the taste, and another day to judge the odor. And so by training the judges to look at it this way, we tend to avoid the proximity error. I don't know that we completely avoid it. We've never done an experiment on it. That would not be a difficult experiment to do. The next order is the time order error. The time order error is the error when the position in the test affects the results. The most important time order error that we have is the first sample prejudice, or first sample preference. We tend to prefer the first sample. And if you're going to be if you're working in a laboratory, suppose you're working in a new product development laboratory, and you spent $15,000 of the company money and a lot of your time to develop a new cookie. And it's the day when the stockholders and the boss is coming in to judge it. For goodness sake, put your new cookie first. Don't tell them you're doing it for that purpose, of course, because they're sure to like it. And why is it that people prefer generally the first sample? Because they have no frame of reference with respect to how good it really is. They go into the situation cold, and they say, well, I've got to give it some score, and after all, it's here, and I might as well give it a good score. So they give it a score of 15. When the second sample comes around, then there is a framework of reference. And they may immediately see, well, I gave that one too much the first one, so now I've got to give this one even more. We gave it 15 when it was first, Then you have to give it 18. And you get in all kinds of problems with the time order error. Now that's one kind of time order, the first sample prejudice. In the triangular taste test, we have another time order error. The time order error in the triangular taste test is the preference for the middle sample, or the prejudice against the middle sample, or the tendency to select the middle sample more often as being the different sample. And this is significantly significant. If you give them 3 samples that are not different at all, they'll pick the middle sample as being different from the other 2 more than they will either one of the others. We figure that this is due to the fact that people like to have balanced situations. And the only way that you can, in the triangular taste test, that you can have a balanced situation is to have the middle one different than the 2 side ones. Because otherwise, if the first one is going to be the same and the other 2, the second and third, are going to be the same, well, that's going to be unbalanced in one direction. Or if it's the last sample is the different one and the first 2 are the same, that's going to be unbalanced in the other direction. So the only one that's balanced in our mind in this is the middle one, and so we tend to statistically pick that one more times than we should. There have been some cases where the last sample has been preferred, statistically significantly. I don't know what the reason was in the particular one, but I can think of reasons that it might have occurred. The last sample, suppose you're tasting 5 sauerkraut samples. When you get to the 5th one, you know it's the last one. You may say, well, thank goodness, and give it a score that's more than it should be, because it is the last sample. You can avoid these time order errors, of course, by reversing the order. And that's what many people don't do. But really reverse the order. Don't just keep, as was done yesterday on the grape samples, just keep the same order, but just start with a different sample each time, because that doesn't eliminate the time order error. You've got to have them in all possible combinations. 3 has got to occur in front of 4 and after 4, the same number of times. So it's better to use random numbers for doing this sort of thing and eliminate these orders. Now the association error. The association error, I've given you some examples of that. To a conditioned response. Let me refresh my... oh yes, the tendency to repeat previous impressions is what's called the association error. You're judging a group of peaches, and you recognize them, that they're all clones of the same crosses and so forth, or they're different crosses with the same parents, and you find a certain odor in the peach. By association, then, you keep repeating that, because the peaches are really all associated with each other. They all belong to the same family, and even though they have maybe more or less, we tend to not recognize that, so that the conditioned, we have sort of form of conditioned response. You may, as I just said, the second sample you may just neglect it because you've already had that, and you tend to not neglect it. The other thing that actually happens, you may get a stronger response. Having found that special peach odor in the first one, you start looking for it in the second one, and you find that it's much more than really is there. Training will help to reduce the association error, but some people are very subject to conditioned errors. Sometimes whole nations are subject to conditioned errors. In Germany in the 30s, for example, is a good example of that. So don't neglect that, the possibility of a conditioned error. Giving a response simply because something else has happened previously, like Pavlov's dogs. And then last is the errors of the first and second kind, and that's where the error occurs on page 252 in your text, and if you will be sure and take those over. Now memory. We'll stop after part C. Memory is a very good thing to have. It helps, but we don't know exactly how it operates. Does it make the judge respond more quickly? Or how could memory? The experience of the subject, of course, will generally lead him to expect certain things. And when he's expecting certain things, then memory may help him to look for those certain things and to identify them. It's quite true that